Good afternoon, Year 12. I'm recording this video for those of you that feel confident with this work, with what we've covered already in exercises 10C, D and E. If you're not overly confident, please join the Teams lesson. If you're feeling confident and you need a faster pace, watch on. I'm going to give you 3 examples and then ask you to just get on with the work, but please do get in touch if you need any help. Also, at the end of this lesson, if you've not joined the Teams lesson, I would like you please to send me a photo of your marked work so that I can just see where you're up to, how you've got on. You can either attach that on Show My Homework or send it by email. So, first example, this is question 1A from the textbook. We've got 4 cos squared theta is equal to 1. First thing we need to do is make cos squared theta the subject. So by dividing both sides by 4, we get cos squared theta is 1/4. Now your next step is to square root this to make cos theta the subject. But when you square root, you need the positive and negative roots of 1/4. That's because when we've started off with the graph of y equals cos x, when it's been squared, all those negative values become positive when they're squared. And so instead of the usual 2 solutions, we need 4 solutions. So when we square root it, we need the positive root, which will give us these 2, and the negative root, which will give us those 2. So I'm now going to write this out as 2 separate equations. Cos theta equals the positive root of 1/4, so positive 1/2, and cos theta is equal to the negative root of 1/4, so negative 1/2. And I'm going to solve each of these 2 equations within the given range 0 to 360 degrees. Solving the first one, inverse cos of 1/2 is 60 degrees. So the principal value for this equation is 60, and then the other value for theta that we need is 360, take away 60, which is 300 degrees. So there's my first 2 solutions. For the second one, inverse cos of negative 1/2 is 120 degrees, so that's my principal value for this one. And then to find the second solution, again I can subtract that from 360 to get 240 degrees, and there are my third and fourth solutions. Please also watch the video on how to find all these solutions on your graphical calculator. I'll post that as a separate link on Show My Homework. My second example for you then is tan squared 2 theta take away 3 tan 2 theta take away 10 is equal to 0. So we've got a quadratic now where tan theta is the subject, and then we're solving that for theta between 0 and 180 degrees. Now the first step in this one is to change the range to match the angle. So the angle here is 2 theta. So if we double theta in the middle of the inequality, we need to double the upper and lower limits as well. So we're now solving this for 2 theta is between 0 and 360 degrees. Now, if the quadratic will factorise it. If it doesn't, then stick it in the quadratic formula, or you can pop it in the formula anyway, even if it does factorise. But I can see that this one is going to factorise to give me tan of 2 theta in both brackets, and 2 numbers that multiply to make negative 10 and add to make negative 3 are negative 5 and positive 2. So factorising that equal to 0, I can now solve each of these 2 terms equal to 0. If tan 2 theta take 5 is equal to 0, then tan 2 theta is equal to 5. And if tan 2 theta plus 2 is equal to 0, then tan 2 theta is equal to negative 2. So the next step now is to solve each of these 2 equations for all the values of 2 theta within the range 0 to 360. So inverse tan of 5 gives me my principal value here of 78.69 degrees, and I'm giving that to an extra degree of accuracy. And similarly for my second one, tan 2 theta is negative 2, so inverse tan of negative 2 is negative 63.43 degrees. Now, that one isn't in my range, but it doesn't matter because next I'm going to find all my values for 2 theta within the given range. I'm going to start with the 78.69, and to find the next value I need to add 180 degrees, which is always the same for a tan function, add or subtract 180 degrees. So my next value is 258.69 degrees. If I added another 180 to that, it would go outside of the range, 0 to 360, so that's all the solutions I want for that one. The negative 63.43 I don't want because it's lower than 0 as my lower limit, but if I add 180, I get 116.57 degrees, and then add another 180, it's 296.57 degrees. If I added another 180, again that would go over 360, so I'll stop there. Once you've solved for all of the values of 2 theta within your given range, you can then divide them all by 2 to get your values of theta. And there we have it, 4 solutions for theta within the range 0 to 180. My final example for you involves trig identities. So this is question 4b from the textbook. Tan theta is equal to cos theta. Whenever we're trying to solve a trig equation with more than one trig function in it, the starting point is going to be to try and get it in terms of one trig function. So using the trig identity, sin theta over cos theta is tan theta. My first step, I'm going to substitute tan theta for sin theta over cos theta. And then multiplying both sides by cos theta to eliminate the denominator on the left, you get sin theta is equal to cos squared theta. Now we've still got 2 trig functions here, but one linear, one quadratic, and we also know the identity that sin squared theta plus cos squared theta is equal to 1. So the next step is to substitute the cos squared theta for 1 minus sin squared theta. And now we've got an equation in terms of only one trig function, being sin theta, and we can rearrange to get sin squared theta, add sin theta, take away 1 is equal to 0. Wherever we've got a quadratic trig function, we solve it as we would do any other quadratic. If it will factorise, factorise. This one won't, so I'm going to pop it in the quadratic formula. So for this equation we get sin theta is negative 1 plus or minus square root of 1 squared minus 4 times 1 times negative 1, all divided by 2. That gives us the 2 solutions for sin theta is negative 1 plus root 5 over 2, or sin theta is negative 1 minus root 5 over 2. Now the second one, negative 1 minus root 5 over 2, that is less than negative 1, therefore there are no solutions because the graph of sin theta only exists between negative 1 and 1. So now we're just going to proceed with the first one of sin theta is negative 1 plus root 5 over 2. Apply the inverse sine function to get your first solution, your principal value of 38.17 or 38.2 degrees. Thinking about the sine wave between negative 180 and positive 180, we can see that we're only expecting 2 solutions and that they're both positive. So here's our principal value of 38.2. To get our second solution, we subtract that from 180, and that gives us 142 degrees as our second solution. So I hope this video is useful. Anything you're not sure about, just get in touch, join the Teams lesson, send me an email, ask me, and at the end of this lesson you need to send me a photo of your work so I can see what you have completed, please. Thank you very much, good luck and enjoy.